All right, we're in the 8th week of the semester, finish up the first half, and we're well ahead of the game. Next week, you have no school but it's spring break. This week, we're going to cover chapter 4 and maybe chapter 5 as well, because they're pretty quick and straight to the point. So the first one we're going to look at, divisibility. What does divisibility mean? Don't try to read for it. This is from the top of your head. Because remember, when you're a teacher, you won't have a chance to, let me look it up. Because if you do that, then you lose the class. You have to know this. You have to be able to answer questions from the top of your head. What does divisibility mean? And the worse than saying I don't know is not answering. Being stuck there. Well, what do you think it means? Start off with some answer. We'll go from there. Divisibility. What does to divide mean? Yeah, that's you split. The most common one, you have a pie. If you divide it into four pieces, equal pieces, then you split it into 4 equal sizes, pieces. So divisibility simply means this. It means the composition of one number of its prime numbers. In other words, one number, does it fit inside another number if by some multiplicity? For example, if we have the number 8, is it divisible by 2? What does that mean? It means that if I take 8 and divide it by 2, will it equal a whole number? Yes. So divisible or divisibility means the ability of a number to be a component of a multiple component of another. So when we look at divisibility, if something is divisible by another, if one number is divisible by another, what do we look for? How do you know if it's divisible? We know 8's divisible by 2 because if I took 2, how many times is 2 going to 8? 4. 4 times 2 is 8. I subtract it. What is this number called? The remainder. If the remainder is 0, then this number is evenly divisible into that number this many number of times. Like on the sheet I gave you, on the very top. An even whole number. What is an even whole number? An even whole number is divisible by 2 if what happens? If the remainder equals 0. If the remainder is not 0, what does that tell you the number is? If you divide it by 2. Yeah. If the remainder is not 0, then it's not divisible. In other words, it means it's an odd number. is not divisible by 2 because the remainder is not equal to 0. The remainder is usually what? If I take any odd number and divide it by 2, what is the remainder? Again, if you're reading for the answer, I don't want to hear it. I gave you that sheet. I know what's on that. I want to know what you know. Try it. If you don't know the answer, try it. Take an odd number, divide it by 2. Take another odd number, divide it by 2. See what your remainder is. If you don't know the answer, just try out some problems. Teach your kids to do the same thing. Seven's an odd number. How many times does 2 go into 7? 3 times. 3 times 2 is 6. 11 is an odd number. How many times does 2 go into 11? 5 times 2 is 10. You see a pattern forming here? 21. 2 goes into 21 10 times. So if you divide an odd number by 2, what's your remainder? The remainder will always equal 1. So this is how you would define odd and even numbers. An even number can be represented like this. Any number, where n is any number. Any number you give me, if I multiply by 2, will give me an even number. Any number times 2. An odd number is an even number plus 1. Where did these formulas come from? This one is 2 times a number plus 0. It has no remainder. Where did these numbers come from? Do they have names? Yeah, so what's the top number called? The bottom number? This number? Very good. That's if it works out perfectly. If not, well, if I multiply both sides by b, I get that. This is still the dividend. That's still the divisor. That's still the quotient. And then there's the remainder. So as we look at our examples up here, we said odd and even numbers you divide by what? By 2. So our b value is 2. So we get A equals 2. Q is the answer. It's whatever n we get. That's where we get n. So 2n. Now, the remainder is either what? It's either going to be 0 or 1. So if it's even or if it's odd, that's where they came from. Now, the next part, look at how different ways you can represent these statements. So we can say A is divisible by B. Another way, you say A is a multiple of B. Or we can say it backwards. We say B is a divisor of A. B is a divisor of A. That's what its name is. This is what's going to help us also in the next coming sections. Besides, if it's a divisor and we have a remainder of 0, then B is a factor of A. Or we can simply say that B divides A. Okay, these are the formal ways. You can say that B goes inside of A. What is this one? We said this one earlier. A is a multiple of B. What does that mean? A is a multiple of B. We know what A divides by B means. We know that 8 divided by 2 is 4. So 8 is divisible by 2 because it has a whole number, no remainder. What does this one mean? A is a multiple of B. Just backwards. It was A equals a multiple of B. So if remember, this is A and this is B. So if we look at this, if we take a number on the bottom and multiply, this is the multiple. So that's what it means. A is a multiple of B. B times some number equals A. I'm glad you said that because that's the way most people interpret it that way. But the word is means equals. So A equals B times a number. B is a divisor of A. We did that already. B is a factor of A. What does that mean? What is a factor? What's that? That's a quotient. That's a product. What is a factor? I know you've seen it before. For example, in algebra, when you took that in high school, you had x squared minus 4 is equal to x plus 2, x minus 2. These are factors where you take a larger entity and break it up to its smaller components. That's a very complex one. Another one, 8 is made up of 2 times 2 times 2. These are the factors of 8. 8 breaks down to 2 times 2 times 2. How does that relate to what we're talking about here? No. Is 2 a factor of 8? Well, let's see. Let's break down 8 to its smallest pieces. If 2 cancels, then it's a factor. In essence, that's what you're really doing when you do division. You're canceling out what they have in common. And if you think about it, that's the way you always do division when you're assigned problems like this. How would you simplify or give me the answer? How would you work this one out? How do you mean simplify? What would you put there? What makes up 21? 3 times 7. What makes up 28? So what you do, 28 is made up of 2 times 14. 14 is made up of 2 times 7. 5 is itself. 15 is made up of what? Times 5. 2 is itself. 8 is made up of 2 times 2 times 2. A lot of students are taught in school whenever you multiply fractions, always just multiply top by top, bottom by bottom. That's the worst thing you can do. Because think about it. 21 times 5 is 105. 105 times 2 is 210. 210 times 5 is 1,050. Divided by this even bigger number. Then what are you going to do from there? You're going to see what do they have in common. So if you do it this way, it's all. So anything on top can cancel with any number. So the 3's can cancel. The 5 can cancel. The 7 can cancel. So what do I have left on top? On the bottom, I have 2 times 2, which is 4. 2 times 2, which is 4. 4 times 4 is 16. There you have it. If you break your numbers down to smaller components, factor them, and all you have to do is remove what's the same top and bottom. Oh, yeah. I'm going to show you this statement also. Have you ever seen that before? Again, this is why I don't like the term PEMDAS, because this is nowhere in PEMDAS. The way you read this is B divides A. Which means it looks like this. Or Now, are these the same thing? No, because this is simply a statement that says B divides A, meaning B is a factor of A. It doesn't tell me what the answer is. It simply tells me that B is a factor of A. Or I can say that B is not a factor of A, or B does not divide A. On a side note, linguistically, this is confusing to people in Poland because in Poland, an L with a line through it has a W sound. Actually, my name is supposed to be Migawa. But when my parents immigrated, since they didn't know what that meant, they thought it was a T, but that didn't sound right. So they took the thing and just made it an L. So this kind of stuff, depending on where you are in the world, means something different. That was a side note. It was free. All right, let's look at, oh, let's define divides. It's on your sheet. Definition of divides. So it says for any whole numbers A and B, where B does not equal 0. Why is that important? First off, what is a whole number? 0 to infinity. So any number from 0 to infinity where B is not equal to 0 B divides A if and only if A is a unique whole number Q such that A is equal to BQ. We actually defined this already, but this is the formal definition. For any whole numbers A and B, where B is not equal to 0, B divides A if and only if, that's what that means, A is a unique whole number Q such that A equals, in other words, what this thing says is this. It says B divides A equals some whole number, some quotient. This is true because if I multiply B to both sides, then I get A equals BQ. Then that has to be true. And that's what we write. So B divides A if and only if A is equal to BQ. That's what it says. This is how you write mathematically. Let's get to our first example. Example 1. Classify each of the following as true or false. T or F. A. Is that true or false? Look at this. B divides A means, and that implies that. So B divides A means that if that's true, it equals some Q number, that means it's a multiple. So how would we write this? B divides A. So this one means divides. Is that true? Yes. So it's true. B. 0 divides 2. True or false? What it says up here. B divides A means this. So how would this one look? Why? Right, because anything times 0 equals 0. So 2 does not equal 0. So it's false. Besides, anything divided by 0 is undefined. C. 0 is even. Think of the formulas we just talked about. What is the formula for an even function? Or an even number? A number is even if it has what formula? 2n. 2 times n. So is 0. So is there a number n I could multiply to this to make it equal 0? Yeah. So it's true. Go ahead and work the other ones out with your neighbor. Put it on pause. D, true or false? Why? It says 8 is not a divisor of 2. So that would be true. What it says here is 2 divided by 8 equals some unique number. So is there any whole number Q that when I multiply it to 8, I get 2? No. So it's true because it's not a divisor. You're right, but it's not what that was asking. E. For all whole numbers, we have 1 is a divisor of A. So we have A divided by 1 equals some divisor, some quotient. So when is this true? Remember, this has to be unique. Only true if Q is equal to A. So F for all non-zero whole numbers A squared is a divisor of A to the fifth. True or false? How would you write this as an equation? Because there are 5 A's on top. There are 2 A's on the bottom. And if they cancel, I have 3 A's left. So it's true because A to the fifth only works if my quotient is A to the third. It only works if that's true. G. Three divides 6n for all whole numbers n. Why? It's true only if Q equals 2n. Is that what you got? Yeah. Because 6 is made up of 3 times 2 times n. They both have a 3, so that means Q has got to be 2n. It only works there. That's the unique answer. So true. H. 3 does not divide 5 times 7 times 9. True or false? We have to first look at, okay, how would this be written? 5 times 7 times 9 times 11 plus 1 divided by 3. First off, okay, so it equals some Q. 3 is an odd number. Does 3 go into even numbers? 6, 12, only some of them. But the product of all of these odd numbers is going to be what? Odd or even? Product, whenever you multiply two odd numbers, you get an odd answer. So if you multiply four of them, it's still going to be odd. The 3 can cancel with the 9. It's still odd. Odd plus 1 makes it an even number. So what we're looking at here is saying that it's true for some unique, like Q equals 2. Then it's even. I. 0, oops, 0 divides 0. True or false? Why? So that means any number I put in for Q works, right? Does that mean it's unique? Remember, Q has to be unique. Is Q unique? No, because any number I put in there is true. So this is false. Because Q is not unique. And we have one more. J. For all non-zero whole numbers, A divides 0. So we can look at this as 0 divided by A equals some quotient. Is this quotient unique? When is this true? Remember, A is not equal to 0. It only works one time. It only works if Q is equal to 0. A is not 0. It's everything else but 0. So the only way that this would work is Q is 0. So it is unique. So far, so good. So let's look at our next theorem, theorem 4-1. Theorem 4-1. For any whole number numbers A and B, if I should go A and D, the divisor. If D divides A and N is any whole number, then D divides A times N. Which is what we were just looking at. Another important factor is the next theorem, 4-2, because it gives us a whole bunch of different properties that we have to live by. For any whole numbers A, B, and D, where D does not equal 0, the following is true. If D divides A and D divides B, then D divides A plus B, the sum rule. If D divides A and D does not divide B, then D does not divide A plus B. What it's saying here, then, we know if you have a number, say 15. 15 can be made up of 10 plus 5. If 5 goes into 10 and 5 goes into 5, then 5 goes into 10 plus 5. But if it doesn't fit into one of them, then it can't go into the sum. C, if D divides A, D divides B, and A is larger than or equal to B, then D divides A minus B. Why is this last part important? Yeah, because it has to be greater than or equal to 0. If B is bigger than A, then we'll have a negative number, and that's not in our whole number system, because we're talking about whole numbers only. So it works with addition and subtraction. If D divides A, D does not divide B, and A is larger than equal to B, then D does not divide A minus B. In other words, if it doesn't satisfy both of them, if it's not a divisor of both of them, then it doesn't work. Just greater than? Oh, yeah, you're right. Why is that important? Very good. Because you don't want to have a zero on the bottom. And the last one, it says if D is not divisor of A, D is a divisor of B, and A is greater than B, then the same thing. D is not a divisor of A minus B. What this really tells us is you can add and subtract as long as the divisor is a divisor of both terms. But the corollary is this, it doesn't matter because we can expand that for any whole numbers A, B, and C, and D, where D is not equal to 0. D is a divisor of A, D is a divisor of B, and D is a divisor of C. Then D is a divisor of A plus B plus C. There is no limit how you can expand as far as you need. It becomes more complex when you have subtraction. Because when you have multiple subtractions, you have to make sure you can't equals negative. So we can't say A minus B minus C, because now you put a whole bunch of conditions on B and C. All right, let's look at example 2. Where's example 2? There it is. Classify each of the following as true or false, where X, Y, and Z are whole numbers. If the statement's true, prove it. If it's false, find a counter example. If T, prove it. If false, find a counter example. A. If 3 divides X and 3 divides Y, then 3 divides X times Y. True or false? Y. Look at theorem 4-1. Theorem 4-1 says if D divides into A and N is any whole number, then D divides into N times A. Well, for these, we're saying they're all whole numbers. They're all whole numbers. So X and Y are whole numbers. Here, in theorem 4-1, N and A are whole numbers. So is D, but it can't equal 0. So this is a true statement. Because if 3 is a divisor of X and 3 is a divisor of Y, then the product of that will still be a divisor. 3 will still be a divisor of that. For example, 3 is a divisor of 3. 3 is a divisor of 21. These are both true statements. So that means 3 is a divisor of 3 times 21. Does 3 go into 63? Yeah, 21 times. So that's a true statement because of 4-1. B. If 3 is a divisor of X plus Y, then 3 is a divisor of X and 3 is a divisor of Y. True or false? Why? Okay, so we're saying here is if. Here's the if part. 3 is divided. Give me a number that 3 goes into. 9. I'm saying here that 9 is made up of 7 plus 2. Is 3 a divisor of 7? Is 3 a divisor of 2? So this is false because of this example. True, I know. It jumps in straight because you're going to look at it and that works. But then whatever works, can you break it down to numbers that don't work? There's a counter example. Like if it was 6, 4 plus 2, 5 plus 1. Because we're all thinking 3 plus 3. That's a beautiful world, but it doesn't work. C. If 9 is not a divisor of A, then 3 is not a divisor of A. In other words, is there a number that 9 does not divide into, but 3 does? That's it. It's easier to find counterexample first. 15 would work. Does 9 is not a divisor of 15, but 3 is a divisor of 15. So that's false. It didn't give us any conditions for A. It just says in general, for any A, 9 is not, if 9 is, then 3 isn't. This is false because I could find a counterexample. Now let's look at D. If D is a divisor of X plus Y plus Z, and D is the divisor of X plus Y, then D is a divisor of Z. So if D is a divisor of X plus Y plus Z, and D is a divisor of X plus Y, then it must be divisor of Z. Is that true or false? Which theorem will we look at? The corollary, yeah, the multiple one. Yeah. So according to theorem 4-2, the corollary of it, now, since it's divisors of X and Y, then we can add them together. So now we can look at this and this. Since they're both divisors, then we know that that has to be true. Because since this exists and this exists because of this, then we can subtract them. What is X plus Y plus Z minus X plus Y? So it's true. That was a thinking one. But remember, for these to be true, they have to be unique. For B dividing A or divisor A, it has to equal some unique number. Think of the first example we did. Let's look at example 3. Okay, example 3 is a long, drawn out one. It says, Coach Edgerton bought 9 pair of basketball shoes for team players. She gave the shoes to the student manager, saying, make sure each player pays for a pair of shoes. Each pair of shoes costs the same, and the receipt is in the bag. So we'll be able to figure out how much each, how to charge each student. The student manager found the wet receipt with last digit erased. The total cost said 5-3. 5-3 blank. Despite this, the manager figured out what to charge each player. How did the manager do this? What missing digit? Let's see what we're given here. We're given 9 pair of shoes. The cost was 5, 3 blank. So what are, see, the student manager found the receipt. Message erased. Cost said 539. This one's difficult because we have to figure out numbers that a 3-digit number is divisible by 9. How do we know what numbers are divisible by 9? Look at the sheet. The divisibility rule for 9. How do you know a number is divisible by 9? A number is divisible by 9 if the sum of the digits is divisible by 9. So 5 plus 3 plus what number gives me an answer that I can evenly divide it by 9? 5 plus 3 is 8. So what number can I add to it that's a number divisible by 9? Yeah, it can't be 0. It can be 1. Can it be 2? Can it be 3? 4, 5, 6? No. So 1's the only one. So 531 is the price. Because it has to be divisible by 9. So now to figure out the price that each student has to pay, we divide 531 divided by 9. How many times does 9 go into 53? Yeah. 9 times 5 is 45. Subtract that. We can't. So 13 minus 5 is 8. 9 goes into 81 9 times. So each person has to pay $59. Which brings us to our next section. Divisibility rules. Yeah, there are a whole bunch of, I took all these theorems and put them all on this sheet for you. For one, I even found a couple extra ones because they stop at 11. I went all the way to 13. Yes, you could, there is a way you could do it on calculators. It is possible to determine if a number is divisible by 17 by using a calculator. Using the integer button. INT stands for integer. So the division is performed by using the following sequence of numbers. The number you're looking into, integer 117. You're only looking for this remainder. If the remainder is 0, then 17 is, this number is divisible by 17. And that's how many times 17 goes into that number. But that's a calculator. Again, I don't use those. This is just, look at this came in there. So you can practice that on your calculator if you can find the INT divide button. But I'm interested in these. The first rule, divisible by 1. Every number is divisible by 1. If it's divisible by 2, A number is divisible by 2 if the last digit is even or 0. It could be 80 numbers long. If the last digit is 0 or an even number, then the whole thing is divisible by 2. Divisible by 3. If the sum of all the digits is divisible by 3. Likewise, like we just figured out the last example, it's the same way we do 9 as well. If we add up all the digits and is the sum divisible by 9. A number is divisible by 4 if the last two digits is divisible by 4. Like 516, is that divisible by 4? Is the number 516 divisible by 4?
Yeah.
Why?
516. 516.
Nope. It says divisible by 4 if the last two digits is 16 divisible by 4. Yep. So that means 516 is divisible by 4. Divisible by 5 if the last digit is 0 or 5. It's divisible by 5. A number is divisible by 6 if the number is divisible by both 2 and 3. So what's the rule for 2? It has to have a 0 or an even number in the end. And if you add up all the numbers, it has to be divisible by 3. 7 is the most difficult one. A number is divisible by 7 if the last digit is multiplied by 2 and subtracted from the remaining numbers until you only have a single digit and the remaining number is either 0 or 7. It's a process. $49. Is that number divisible by 7? Yeah, we know it is, but let's use this rule. A number is divisible by 7 if the last digit is multiplied by 2 equals 18 and subtracted from the remaining numbers. So 40 minus 18 is 22. Take the last digit, multiply by 2, you get 4. So we get 20 minus 4, which is 16. 6 times 2 equals 12.
Would it be 18 minus 4 to start it off? And then divide it by 7?
Yes. I did. I read it wrong. You're right. So it's 18 minus 4 is 14. Let's try this one now. So take the last digit times 2 is 8. Eight minus 1 is 7. Yeah. Because 18 minus, okay, this, we had 49. Take the last digit, multiply by 2. Take this number, subtract it. So now we have 14. Take this digit, 4 times 2 equals 8. Subtract this digit. And it's either 0 or 7. Very good. Stupid instructions. Now, number is divisible by 8 if the last 3 digits are divisible by 8. Divisible by 9 if the sum of the digits is divisible by 9. Divisible by 10 if the last digits is 0. 11, another difficult one. The number is divisible by 11 if the sum of the digits in the even spaces minus the sum of the digits in the odd spaces is divisible by 11. This isn't 1, 2, 3. Those are the odd spaces. And these are the even spaces. So if the sum of the digits in the even spaces, which is 4 plus 5, minus the sum of the digits in the odd spaces, 9 plus 1 plus 3, the number is divisible by if the sum of the odd digits. Oh no, not position, not location. Odd digits. 9, 1, 3, and 5. In the even spaces, 2 and 4, minus the odd spaces, 1, 3, 5. So since this number is not divisible by 11, no. Let's find one that is. So we have 11 times, let's say 40. 11 for that. So here's the first and third, and the second. So it's 4 minus 4 equals 0. That didn't work too well, even though we know it's divisible. The sum in the even spaces minus the sum of the digits in the odd spaces is divisible by 11. Well, 0 divided by 11 is 0. It's got no remainder. Let me look into that one again. I may have typed it wrong. Divisible by 12 if it's divisible by both 3 and 4. Divisible by 13 if the sum of 4 times the last digit and the remaining digits is divisible by the remaining 13. I gotta find that one again. I might mistype that one. But yeah, you have the most part here. Unfortunately, you guys have to go. We'll look at the examples next time, and then we'll do the next section. Sorry about that.